This is the end of the section Introduction to Kubernetes. Let me recap this section using a few diagrams to make sure you understood the concepts. I showed you how to deploy a first application to the Kubernetes cluster. First, I showed you how to create a container image using the Docker command line. So we created locally an image, we tagged it, and then we uploaded the container image using the Docker push command to Docker Hub. So at this point, Docker Hub has a container image called Kubernetes example. Next, I created a first pod, Kubernetes example, and this is the definition of this first pod. What is important here is that we defined a container. We can define one or more containers in a pod that will run on the Kubernetes cluster. This container image uses the port 3000. That's why I defined a port with the name Node.js port, and the container port to contact the server is port 3000. This launched our first pod on the Kubernetes cluster. We used the command kubectl create to send this YAML file to the Kubernetes cluster, and Kubernetes launched this pod. What Kubernetes is going to do then is going to pull the image from Docker Hub, because we defined that image in the YAML file. So it pulls this container image and it starts running the container in this pod in Kubernetes. Next, we want to contact the pod. And because we don't have a service yet, we need to use another way to contact it. One way that you can use to contact a pod from your local machine is using port forward. So using kubectl port forward, and the name of the pod, and then the ports that you want to use. The first port is a local port on your machine that you want to open, and the second port is the port of the pod, in this case 3000. Once we enter this command, we can use our browser on our local machine or a curl command to contact our pod, and we can do that on port 8081. Port forward is not the regular way that you would contact an app. It's just a way for us to contact the app locally because we are administrators of our Kubernetes cluster. The real way to contact a pod is to create a service. So that's what we did next. We created a service. We defined the YAML definitions and we used kubectl create to create the service on the Kubernetes cluster. This, for example, is a YAML definition for a service for the Hello World service that is of type load balancer. If you are on the cloud, on AWS, on Google, on Azure, you can use type load balancer to put a load balancer in front of your service. So this will launch, this will spin up a load balancer on AWS, and then you can contact this load balancer on port 80, because port 80 is defined here, which is a standard HTTP port, on the load balancer host to contact your app. This is a normal way to contact your app, because then you expose your app to the internet, everyone can contact it. Load balancer is not the only way to expose a service. There's also another way to expose a service using a node port, which will just open a port that you define, or when you don't define a node port, it will choose a random port, and it will open that port on every single node of your cluster, except the master node. So that way it doesn't create a load balancer, but it opens a port on your Kubernetes cluster nodes so that you can contact your app. This can be useful, for example, if you're going to deploy on-prem, where you don't have a load balancer, then you can use a node port. There are different ways to contact your app, and you will see in the next lectures, in the next sections, different ways that you can contact your app. These are just two ways that I just showed you. Now you might ask yourself, why do we need this service and why don't we just contact the pod directly? Why can we not just put a load balancer in front of a pod? Well, now we have only one pod, but we might have more than one pod. We might have 5 pods. So the service that we create makes sure that we then load balance the requests over the multiple nodes in case that we have multiple nodes. In Kubernetes, we'll always have pods and we'll always put services in front of them. And from outside, we'll always contact the service first, and the service will make sure that your requests are routed to one of the pods that you are running. Let's say that your pod is malfunctioning, pod 1 is malfunctioning. There are ways that you can use to debug the problem. First of all, you can use kubectl attach to attach to the pod to see what is happening. You can maybe see some output that will help you debug your problem. You can execute a command. For example, if you execute the command bash or sh, it will open a shell, and then you can type more commands to debug your problem. Or you can also use kubectl logs to show you the logs of the pod. Maybe there is something in the logs that can help you. So these commands are very helpful to debug issues with your pod. Then there's another possibility. You can also launch a new pod. For example, you can use kubectl run to launch a pod busybox that is using the image busybox to then pull the image busybox from Docker Hub and launch it in a pod. You will then execute the command sh in that pod, and then that will then open a shell, and it allows you to execute more commands to debug the problem. You could, for instance, connect from this busybox pod to the Kubernetes example. So that's it for the recap. I hope I made it a little bit more clear what we try to achieve in the first lectures. In the next lectures, I'll go into more details on how you deploy applications on Kubernetes and how the architecture of Kubernetes really looks like.